I forgot my calculator.
Okay.
When we got Lewis, I thought for sure. I know. Because Lewis is like Lewis isn't a very good ball. No, and he kept running trap.
Okay, we got day 2 for both sections today. All we're really going to do is practice some bearings, because I talked about bearings the first day and you didn't do so hot on that. Practice bearings, and then the only difference between the 2 days was the first day you were given 2 angles and a side, and the second day you were given 2 sides and an angle. And it came up angle, side, side, you had to remember to check for the second triangle. So now they're all going to be mixed together on today's homework. So when that angle, side, side shows up, you got to tell yourself, check for the second triangle. So, notes are fairly short today, but like I said, let's practice the bearings, because that seems to be the sticking point. So here our situation is we have 2 watchtowers that are 113 miles apart on an east-west line. So the person in the west tower spots a fire. So from the west, the fire is at a bearing of north 42 degrees east. The person in the east tower, 113 miles away, also spots the same fire. The fire is on a bearing of north 15 degrees to the east. With that information, can you find the distance from the western tower to the fire? So it's good old bearings. If you take story problems one thing at a time, you'll be all right. What would you draw first to start drawing this situation? Carter?
East-west line.
Absolutely. East-west line. We know an east-west line what it looks like. Give yourself some room. This triangle's going to grow vertically on us, so I'm going to come down here. East-west line. And you got your 2 watchtowers located on that. And we know that they are 113 miles apart. And now it's just know your east from your west. Which one you're going to call W here for west? The left one. So know your compass directions. Alright, so now we stand in this western tower. And it says to see the fire, you have a north reference line. You're going to rotate 42 degrees toward the east. So always put a reference line in. So north is the reference. Show the rotation of 42 degrees. Along that line of sight is your fire. I want it right off my paper. 42 degrees is this rotation. Okay. Now move over to the guy in the eastern tower. His reference is north, but he's only got to turn 15 degrees toward the east to see it. So north reference, just 15 degrees over, so not much. So the fire is actually to the right of both people. So it's over here. I'm going to make that touch. So my triangle did happen way up here. Yeah, there's my fire way up there. And make sure you get that angle in the right spot. That 15 degrees is from the north over. And then the question said, find the distance from the western tower to the fire. That's this side of our triangle. All right, now your work begins. You got to find some angles in that triangle. What can you find? Sam? And that will give you the angle inside the triangle. There's a big old 90-degree angle here you're supposed to recognize. So 90 minus 42 for this one leaves us 48. Okay, can you get another angle inside of the triangle? Carter? 15 plus 90 will get you this angle inside of the triangle. So 105. And now we're ready for law of sines. Almost. Because I'm looking for this x side. What is x across from? The 105. Okay, that's not a problem, except I can only have that unknown, which means 113 is across from the angle up at the fire, which we haven't found yet. But can we find the angle up at the fire? Little 180 trick, because we've got these two here. So the angle up at the fire is 180 minus the 48 minus the 105. Anybody got that number for us? 27 degrees up here. So now we're ready for our proportion of 113 over the sine of 27. So 113 over the sine of 27. Our missing side over the sine of 105. And again, law of sines is pretty easy. Once you get your triangle drawn, I don't think the law of sines is a big issue. And then it says cross products on your calculator and divide. So it's multiply, divide. I got 240. Good? Yep. All right, next story problem, a little tougher than this one. There we are. Okay, number 2. We've got a river flowing north. I'm not going to write down all the words I say. And you've got Mark and Lisa on one side of the river, and you've got a tree on the other side of the river. So from Mark, the bearing of the tree is 115.45 degrees. Lisa's on the same side of the river as Mark, but her bearing from the tree, the bearing of the tree from her, she's only got to turn 45.47 degrees to see the tree. We know that Mark and Lisa are 428.3 meters apart. Can you find the distance across the river? Are you ready? That was fast. Okay, what are you going to start with? That river flowing north. So here's one bank of the river. Here's the other bank of the river. We've got Mark and Lisa on one side of this river. And they are 428.3 meters apart. Do we know which one's Mark and which one's Lisa? Can you tell from that information based on how much they have to rotate? Peter?
Mark's on the top.
Mark's on the top. He is north. And all you have to do there is you just take a guess at it. If you draw your two lines and your two lines of sight don't cross, You switch them around, then they will cross. But he's got it right. So how do we show this now? So from Mark, the bearing of the tree is about 115 degrees. So you need a north reference line. If they don't tell you, it's automatically north. We're going to rotate over about 115, so there's 90, a little bit more. So there's the tree on the opposite side of the river. So that 115.45. Now from Lisa, the bearing of the tree, you always need that reference line. So we are now Lisa, we need a reference line which is north, which is that edge of the river. We rotate over 45 degrees from there. So it's that. And we need to also see that same tree. Okay, the question is, how far across the river is it? Find the distance across the river. Well, are either of these two sides of the triangle the distance across the river? No. The distance across the river, when we talk distance across, we want the shortest perpendicular distance. We are looking for, okay, pink, this distance here. That's what we're looking for. Now, biggest mistake students want to make is, oh, I just divide this into two right triangles where these two pieces are equal. Those are not going to be equal because you can see, well, once we figure out this angle over here, these two angles are not going to be the same. So that means these sides are not going to be the same, so these pieces are not going to be the same. All right, so don't do that. So let's first find the angle inside of our triangle up here. How are we getting this? Yep. So 180 subtract that out there. 115.45. So that leaves us with 64.55. Okay. Can I do anything with either of these two right triangles to set up an equation with x right now? I have to know at least one side length to do that. Do I know any side lengths on these right triangles? I don't know that. I don't know that. I don't know that. Don't know this. Don't know this. I can't find x right off the bat. That's impossible. But if we look at the bigger triangle that we started with, I can find either of these two sides first. Once I have that, then I can come back to one of the right triangles and find the x. So it's a two-stepper. So we can find little m or we can find little l. It doesn't matter which one. We only need one of them. I'm going to shoot for little m with law of sines. Once we've got that, then we'll come back and do a little SOHCAHTOA in here to get the x. So 2 steps. Am I ready to start this thing? What is the 428.3 across from? Big T. I need angle T. So I got to do that before I get started. So that's a 180 minus the 64.55 minus the 45.47, 69.98. And now we're ready for a law of sines proportion. So 428.3 over the sine of 69.98, and I'm looking for little m, and that is across from the 64.55. So I see multiply and divide. I'm getting, let's see, 411.6. Now you're going to put yourself inside of this little right triangle. I'm going to use SOHCAHTOA stuff. You can use law of sines because we got a side and an angle, an unknown side and a known angle. We could do law of sines, but I don't practice SOHCAHTOA. So I'm going to stand here. The x is on the opposite side. This 411 is on the hypotenuse. So I am setting up a sine again. So it's the sine of 45.47. Opposite is the x. Hypotenuse is the 411.6. Multiply and we'll have the distance across that north flowing river. And I'm getting 293.4. So you may have to find something else before you can get to the actual question that's being asked. No. Not quite. Got something new for you. Brand new. Easy though. Area of a triangle. You've been finding area of a triangle since about 5th grade. What's the one formula you have for that? Base times height over 2. Well, now I'm going to introduce you to another area of a triangle formula. So the area of a triangle can be found if you know two sides and the included angle. It has to be the two sides with the included angle. That means one side, a second side. It must be the angle connecting those two sides that you know. That's the only way this formula I give you works. And to find the area of this triangle, very easy plug and chug formula. It's 1/2 times one of the side lengths times a second side length times, I'm running into it, the sine of that angle. So 1/2 times side times the sine of the angle. Find the area of, if I know this, B is 124.5, A is 30.4, C is 28.4, and little b is 42.6. Label it up. A is 30.4, C is 28.4, and little b is 42.6. Okay. What three parts in here are going to make SAS, side angle side, so we can use that formula? What's the extra information that you don't need? Franklin?
Stuff I needed, little a, little c, and big B.
Little a, extraneous, great word. This is extraneous, not needed, don't use it. It has to be the three parts that are in the SAS position. So, it's just 1/2. Simple, 28.4 times 30.4 times the sine of 124.5. Well, I want to point out what happens on a test. This will be the question. Find the area. And people will go through and solve this thing. They'll find angle A, they'll find angle C, and if I didn't give you, they'll find that, solve it, and move on. Well, what do I have to do if I'm checking that and you never answered the question? -5 for you. Be careful, Sean.
Why is it minus?
Why? I don't know, 'cause it was find the area.
Why is that minus 5?
Well, maybe 4.
Minus 1?
1? 1 point for that? Knowing which area, because we're going to have another area formula coming your way soon, next year. But, find the area. Don't go through and solve and do all this extra work for no good reason and get no points for it. Read questions. Anyway, did anybody crank through that? Otherwise, I'm just moving on.
355.8.
So, 355.8, it would be square units of some sort. Almost. I just want to, one more. We're not going to finish this one, because I'm going to squeeze it in here. We're not going to complete it.
It's not even started.
We are going to start it. It's a solve the triangle. If you can tell me what I want to hear, I'm not going to finish it. Angle A is 55.3 degrees. Little a. Yep. 22.8. And little b is 24.9. Alright, labeling it up. A is 55.3. Little a is 22.8. And little b is 24.9. Tell me what I want to hear so we don't have to complete this problem. It's ass. Angle side, side, which means check for second triangle. When you label the triangle up on all of these solved ones, when you label up the 3 parts, train your brain to look at the positioning, because this one time, when they're in angle side, side, that's when you got to do what we did yesterday, and remember to tell yourself, I got to check for that second possible triangle. Which you do after you find the first angle, you subtract from 180 and make a little table. Okay, that's all I needed you to tell me. We won't finish that one.
We got a worksheet today.
You got a worksheet today?